On the morning of July 15th, 2026, at roughly 10 o'clock local time, a Russian Mi-28 Night Hunter attack helicopter was flying low over the Belgorod region, somewhere near the village of Vyazovoye, when a small, cheap, first-person view drone caught up with it and struck its tail boom. Within hours, the commander of Ukraine's unmanned systems forces, Major Robert Magyar Brovdy, posted footage of the engagement and declared that the helicopter had gone down. The unit credited with the strike was the 427th Separate Unmanned Systems Regiment, known by its call sign Rarog. For a war that has been defined by trench lines, artillery duels, and endless waves of exploding quadcopters chewing through infantry and armor, this single engagement stood out. It wasn't a truck, it wasn't a tank, it wasn't a stationary target sitting in a field. It was a fast-moving, armed twin-engine attack helicopter, one of the hardest things in the sky to hit with a drone that costs a few $100s and flies barely faster than highway traffic. That mismatches the whole story. And it's worth slowing down and actually understanding why, because the tactical puzzle involved here says a lot about where this war is heading, and maybe about where a lot of future wars are heading too. Start with the machine that got hit. The Mi-28 is one of Russia's primary attack helicopters, built originally as a rival to the American Apache, and more directly, as a counterpart to Russia's other attack helicopter, the Ka-52 Alligator. It's a gunship designed to hunt tanks, armored columns, dug-in infantry, and low, slow aerial targets. It carries a 30mm cannon, guided anti-tank missiles, unguided rockets, and in some configurations, air-to-air missiles for self-defense. It is armored around the cockpit. It is fast by helicopter standards, capable of speeds well over 100 miles an hour, and it has been a genuine problem for Ukrainian ground forces throughout this war, since it can loiter behind Russian lines and fire standoff munitions at armor and infantry without needing to cross into contested airspace. Ukraine's own military has put a price tag on one of these aircraft at somewhere around $18 million. Estimates elsewhere put the broader Mi-28 family in a similar range, sometimes higher, depending on the variant and its avionics package. Whatever the exact number, the point is the same. This is a multi-million-dollar weapons platform built in a factory, requiring years of pilot training to fly, requiring a logistics chain to fuel, arm, and maintain. Now put an FPV drone next to it. First-person view drones are, at their core, hobbyist racing quadcopters that have been weaponized. The frame, the motors, the flight controller, the camera, the video transmitter. Most of that hardware traces back to a civilian hobby industry, much of it built around cheap components originally intended for drone racing and aerial photography. Add a warhead, sometimes a repurposed piece of unexploded ordnance, sometimes a purpose-built shaped charge, and you have a flying bomb that a single operator can steer through a set of first-person video goggles from a bunker or a tree lined kilometers away. These things cost a few $100 to a few $1,000s depending on the build. They are individually almost disposable, and they are individually nowhere near as fast as a helicopter. Even fast racing style FPV drones top out well below what a Mi-28 can do in level flight. So the first and most obvious problem facing anyone trying to use one of these drones against a helicopter is speed. You cannot chase a Mi-28 with an FPV drone. If the helicopter sees you coming and simply keeps flying in a straight line away from you, you lose every time. The intercept has to happen because the drone got somewhere the helicopter was going to be, not because it caught up with somewhere the helicopter already was. That single fact reframes the entire engagement from a chase into a prediction problem. It's closer to what an anti-aircraft gunner does when leading a moving target, or what a goalkeeper does anticipating a penalty kick, except stretched out over minutes instead of milliseconds, and complicated by the fact that helicopters flying combat patrols near a border do not fly straight, predictable lines. They hug terrain. They use ridgelines, tree belts, and river valleys to break line of sight with observers and to make themselves harder to track on radar. They vary altitude. They change heading to avoid predictable corridors, precisely because experienced pilots know that predictability is what gets you killed in a contested airspace. So the challenge for Ukrainian drone operators wasn't simply, how do we make a drone that can carry a warhead? That problem was solved years ago, in the earliest days of FPV drone warfare on the front lines, when volunteers and soldiers alike started strapping RPG warheads and mortar rounds to racing frames. The much harder problem was, how do you find a fast, low-flying, evasive aircraft with enough advance notice and with enough precision that you can put a much slower drone in its path before it passes by? Ukraine's answer, based on the reporting around this and similar strikes, leans heavily on layered reconnaissance and detection. Ukrainian forces operating near the border have built out extensive networks of forward reconnaissance, informant reporting, and sensor coverage specifically to track Russian aircraft activity, because helicopters and fixed-wing jets flying near the front are simultaneously the most dangerous targets and the hardest ones to reach. Some of this is old-fashioned reconnaissance, spotters, partisan networks inside occupied or border territory feeding back what they see and hear. Some of it is more exotic. Ukraine has been reported to be developing and fielding passive acoustic detection systems, essentially networks of microphones and simple sensor nodes scattered across contested ground, designed to pick up the distinct engine and rotor signatures of aircraft and drones and triangulate their position from the sound alone, without ever having to emit a radar signal that would give away the listener's own position. This kind of passive sensing has already proven itself against Shahed-type attack drones, where cheap microphone arrays cued into artificial intelligence classifiers can pick a drone's engine note out of background noise and hand off a rough position to interceptor teams. Extending a similar concept to helicopters isn't a huge conceptual leap. A helicopter's rotor and turbine signature is loud, distinctive, and travels a long way, especially in the kind of cool, damp, layered morning air that can bend sound waves and extend detection range well beyond what you'd expect on a clear, hot afternoon. Whether or not this specific engagement relied on that exact kind of system, the broader pattern in Ukrainian drone operations against Russian aviation has consistently depended on getting early, off-board detection of aircraft before they ever come within visual or optical range of the strike team, precisely because visual detection alone gives you far too little time to react. Once you have that early warning, the problem becomes coordination. Multiple accounts of Ukraine's operations against Russian aircraft, ships, and vehicles describe not lone operators improvising, but small, distributed teams working from different positions along a likely flight corridor, each ready to launch and each able to hand off tracking to the next if a target changes course. This matters because a single ambush point is a single point of failure. If a helicopter pilot changes heading, banks around high ground, or shifts corridor to avoid a suspected threat area, a single fixed ambush site is useless. A distributed network of teams spread across the plausible approach routes and kept in constant radio or data contact with each other and with whatever detection network is feeding them updates can shift the intercept point in real time. That is a genuinely difficult thing to organize under combat conditions, with equipment that fails, batteries that behave unpredictably in cold or damp weather, video links that get jammed, and human operators who are tired, cold, and under real-time pressure. It is also, when it works, exactly the kind of layered, networked approach that turns a fundamentally undermatched weapon, a slow FPV drone, into something that can threaten a fast military helicopter. Electronic warfare is the other half of this puzzle, and it cuts both ways. Russian forces operating near the border are not blind to the drone threat. They field their own electronic warfare systems, specifically designed to detect, jam, or hijack the radio links that FPV operators use to control their drones. Systems like these sweep across the radio spectrum looking for the kind of signal an FPV video and control link produces. And once they find it, they try to either flood it with noise or spoof it to force the drone down or send it off course. Ukrainian operators have adapted to this threat the same way operators on both sides of this war have adapted to jamming across the front line generally, through frequency agility, essentially hopping the control and video signal across many different channels rapidly enough that a jammer struggles to lock onto and saturate any single one before the link has already moved elsewhere. Fiber optic controlled drones, immune to jamming entirely because they trail a physical cable back to the operator, have also become common on the front lines for exactly this reason. Though a fiber-tethered drone attacking a fast-moving aircraft kilometers from its launch point is a much harder proposition than a fiber drone crawling along a static ground target. For a genuinely mobile aerial intercept like this one, frequency hopping radio control combined with a degree of onboard autonomy, letting the drone hold a heading or a target lock using inertial sensors, and preloaded terrain data if the video link briefly drops out, is the more practical answer, and it is increasingly common in the more sophisticated interceptor drones being fielded by specialized Ukrainian units. It's worth pausing here to be honest about what is confirmed and what isn't. The core facts of this event are corroborated across multiple independent sources. Ukraine's unmanned systems forces, under Madyar Bravdi, publicly announced the strike on July 15th, released video purporting to show a drone striking the tail section of a Mi-28 near Vyazovoye in Belgorod region at around 10 in the morning and attributed the strike to the 427th Rarog Brigade. Ukrainian and international outlets picked up and reported the claim within hours. What is less firmly established is the ultimate fate of the aircraft and its crew. Ukraine's own commander described the helicopter going down, but the publicly released footage, like most FPV strike footage, cuts out at or near the moment of impact, when the video link is destroyed along with the drone. That is simply the nature of this kind of weapon. The camera doing the recording is also the camera doing the crashing. Independent confirmation of a helicopter loss, wreckage photos, crew casualty figures, or an official Russian acknowledgement typically lags hours or days behind an initial strike claim if it comes at all. In this case, at least one aviation incident tracker noted that Russian sources described the aircraft as having sustained only minor, repairable damage rather than being destroyed outright, which is a meaningfully different outcome than shot down. This is a familiar pattern in this war. The attacking side has every incentive to claim a clean kill, the defending side has every incentive to minimize the damage, and outside observers are often left triangulating between drone footage, satellite imagery, wreckage photos if they surface, and official statements that rarely align. None of that makes the underlying tactical story less real or less significant. Even a Mi-28 that survives a direct hit to the tail boom and limps home for extensive repair, rather than crashing outright, is still a demonstration that a first-person view drone costing a few $100s can reach out and physically damage a multi-million-dollar attack helicopter in flight, which a few years ago would have sounded like something out of a video game rather than a documented battlefield tactic. Why the tail boom, specifically? Any experienced helicopter crew or aviation engineer would tell you the tail rotor assembly is one of the most structurally sensitive parts of a rotorcraft. A main rotor spins one direction and generates enormous torque. Without something counteracting that torque, the fuselage would simply spin in the opposite direction underneath the rotor disc. That's what the tail rotor is for, along with the tail boom's role in overall directional stability. Damage the tail rotor drive shaft, the tail rotor blades themselves, or the structural boom that holds the whole assembly in place, and a helicopter can very quickly lose the ability to control yaw, the rotation around its vertical axis. Depending on altitude, airspeed, and how much of the tail assembly is destroyed, that can range from a difficult but survivable emergency landing to a complete, unrecoverable loss of control. Drone operators targeting helicopters have increasingly focused on this vulnerability precisely because it doesn't require punching through cockpit armor or hitting a fuel tank dead center. It requires putting a small warhead somewhere on a large, thin, mechanically critical structure at the back of the aircraft, which is both a bigger target than the cockpit and a more consistently vulnerable one. Step back from the mechanics of this single engagement and look at what it represents in the broader arc of this war. Ukraine's unmanned systems forces, as a distinct branch of the military, is itself a fairly recent institutional development, stood up specifically because drone warfare had grown from an improvised, volunteer-driven add-on to something that needed its own doctrine, its own training pipeline, its own procurement, and its own dedicated units rather than being bolted onto existing infantry, artillery, or aviation branches as an afterthought. Under Bravdi's public-facing leadership, that branch has become known for a very particular communication style: rapid, almost daily claims of strikes against ships, vehicles, aircraft, and infrastructure, backed by drone footage, posted to social media and Telegram within hours of the events themselves. Whatever you make of the propaganda value of that approach, and it clearly serves a morale and information war function on top of any purely military value, it has also had the effect of making Ukraine's evolving drone tactics unusually visible to outside observers in something close to real time. We are watching doctrine get written and rewritten in public, strike by strike, as operators find weaknesses in Russian countermeasures and Russian forces adapt in turn. The economic argument underneath all of this is not subtle, and it is genuinely one of the more consequential threads running through this entire war. A single Mi-28, at somewhere around $18 million, represents years of manufacturing investment, a supply chain for specialized components, a training pipeline for its crew that itself takes years to produce a qualified pilot, and an ongoing maintenance and logistics burden to keep it flying. An FPV drone that can meaningfully threaten that helicopter, even if it only damages rather than destroys it, might cost somewhere between a few hundred and a few $1,000s, built largely from civilian components sourced from commercial supply chains, assembled in days rather than years, and flown by an operator who can be trained to a reasonable proficiency in a matter of weeks rather than the years it takes to produce a helicopter pilot. That is not a one-to-one replacement of expensive weapons with cheap ones across the board. Helicopters still do things drones cannot: sustained close air support, heavy ordnance delivery, rapid repositioning of firepower across a wide area, but it does mean that the traditional calculus of air power, where dominance in the sky is bought through expensive, hard-to-replace platforms, is being challenged from underneath by a category of weapon that a defending force can produce and lose in enormous numbers without meaningfully denting its own economy.
Every time a strike like this one lands, even a partial hit, it forces the more expensive side of the equation to change behavior. Fly lower, fly less predictably, fly less often, add electronic warfare escort, avoid known threat corridors, all of which either reduces the effectiveness of the expensive platform or increases the cost and complexity of using it at all. There's also a psychological and operational dimension worth sitting with. Attack helicopters like the Mi-28 have historically been used specifically to hunt the kind of ground-based drone operators and light infantry units that have been bleeding Russian forces along this front for years. Part of the stated purpose of the patrol this helicopter was reportedly flying was aimed at establishing a low-altitude presence that could detect and interdict the very Ukrainian drone operations that ultimately brought it down. That's a genuinely interesting inversion. A platform sent out specifically to counter drone operators becomes, itself, the target of a drone ambush, using detection and coordination methods that mirror, in miniature, the kind of layered air defense thinking that used to be the exclusive province of much larger, much more expensive systems. It suggests that the drone war on this front has matured well past the improvised individual operator phase and into something closer to a genuine reconnaissance strike complex. Detection assets feeding targeting data to distributed strike teams, coordinated in something close to real time, capable of adapting an intercept plan mid-engagement when the target doesn't behave as expected. None of this should be read as a claim that drones have made manned aircraft obsolete, or that this single engagement changes the strategic balance of the war on its own. Helicopters and fixed-wing aircraft still provide capabilities no drone swarm currently replicates: sustained firepower, rapid long-range repositioning, all-weather operation in conditions that can ground smaller drones, and the ability to carry far more destructive ordnance than a repurposed fragmentation warhead strapped to a racing frame. Russia will continue to fly Mi-28s and other attack helicopters near this front because the alternative, ceding that airspace entirely, has costs of its own for Russian ground operations. What events like this one actually demonstrate is narrower, but still significant: that the margin of safety attack helicopters have traditionally enjoyed while operating near contested front lines has eroded further, and that a dedicated, well-resourced drone force with good reconnaissance and coordination can now credibly threaten targets that used to be considered outside the practical reach of first-person view drone warfare. That is a meaningful shift in what close to the front line means for expensive aviation assets on both sides of this conflict, and it's a shift with implications well beyond this particular war, since every military planner watching this footage is drawing the obvious lesson. Cheap, mass-produced, networked drones are steadily narrowing the gap between what a small, improvised force can threaten and what only a major air power used to be able to touch. It's also worth noting how quickly this kind of engagement now becomes public record. Within hours of the strike, footage was circulating, official statements had been issued, independent outlets across multiple countries had picked up the story, and open-source aviation trackers had already logged the incident with whatever conflicting damage assessments were available at the time. That speed is itself part of the modern character of this war. Information moves nearly as fast as the drones do, strike claims are contested and counterclaimed in near real time, and the fog of war now includes a genuinely public layer of competing video evidence, official denials, and independent verification attempts happening in parallel with the fighting itself. Anyone trying to understand what actually happened in an engagement like this one has to hold two things at once: the tactical significance of what the footage shows, a drone reaching a moving helicopter and striking one of its most vulnerable points, and the genuine uncertainty about the ultimate outcome, since claims of destruction and claims of minor repairable damage are not the same event, and only one of them can be true. What seems most durable about this particular strike, regardless of how the damage assessment eventually settles, is the tactical template it represents: distributed detection, whether from human observers, passive acoustic sensing, or some combination of both, feeding early warning to multiple coordinated strike teams positioned along plausible approach corridors, real-time replanning when the target doesn't behave as predicted, frequency agile control links, and a degree of autonomous flight to survive electronic jamming, and a willingness to aim not for the most heavily armored part of the target, but for its most mechanically vulnerable one. None of those individual ideas is new to warfare in the abstract. They're recognizable descendants of decades-old air defense and interception doctrine. But assembling them into something a half-dozen operators with racing drones and a handful of cheap sensors can execute against a multi-million-dollar military helicopter is a distinctly modern development, and one this war has been quietly building toward for a couple of years now through thousands of smaller, less dramatic engagements against trucks, artillery pieces, and armored vehicles. This is simply what it looks like when that same toolkit gets pointed, successfully or not, at the sky. It also helps to put this strike in the context of what the Rarog Brigade and the wider unmanned systems forces have been doing in the weeks around it, because a single dramatic engagement can look like an outlier if you don't see the pattern it sits inside. The same command structure that announced this helicopter strike has, in the same general period, publicized a string of attacks on Russian naval vessels in the Black Sea and Sea of Azov, hits on fuel and logistics infrastructure well behind the front, and a running campaign against so-called shadow fleet tankers used to move sanctioned oil. That's a notably broad target set for a single branch of a military to be claiming credit for, spanning ships, refineries, vehicles, and now attack helicopters, and it reflects a deliberate strategic choice. Rather than treating drones purely as a frontline infantry support tool, Ukraine has increasingly treated its unmanned systems branch as a long-range strike force in its own right, one capable of reaching targets that would previously have required manned aircraft, cruise missiles, or naval assets to touch. A Mi-28 shot at over Belgorod and a tanker struck in the Black Sea are, on the surface, completely different kinds of targets. Underneath, they're both examples of the same institutional bet, that a large, well-organized force of comparatively cheap, uncrewed systems, backed by good reconnaissance and rapid iteration on tactics, can substitute for capabilities that used to require far more expensive, far more limited platforms. It's also worth thinking about this from the perspective of the two pilots who were flying that helicopter, because it's easy to let the technical and economic analysis crowd out the human reality of what this kind of engagement actually is. Flying a low-altitude patrol along a contested border, deliberately hugging terrain to avoid radar and observation, using rivers and rail lines as navigation references because satellite positioning in the area is degraded by jamming from both sides, is already a demanding high workload task under the best of circumstances. Doing it in a region where the other side has spent the better part of 2 years building out drone reconnaissance and strike capability, specifically aimed at aircraft like yours, adds a layer of psychological pressure that doesn't show up in any spec sheet. Russian aircrew operating near this border now have to fly with the working assumption that they might be under observation from the moment they take off, that any predictable corridor they use more than once becomes a known threat area, and that a helicopter cockpit's armor and countermeasures, while real and meaningful against small arms fire and some guided weapons, offer far less protection against a slow-moving drone deliberately aimed at the unarmored tail section from behind. That reality almost certainly shapes Russian helicopter tactics near this border already, and incidents like this one only reinforce the pressure to fly less predictably, lower, and for shorter durations, which in turn limits how effectively those helicopters can perform the reconnaissance and strike missions they were built for in the first place. In an odd way, that's success even before you get to the question of whether the aircraft was actually destroyed. A defensive weapon that forces the other side to fly worse, shorter, and more cautiously has already changed the balance of the fight in that stretch of airspace. There's a useful comparison to be drawn with how naval warfare has evolved over the same stretch of this conflict. Ukraine, without a meaningful blue water navy of its own, effectively pushed a significant portion of Russia's Black Sea fleet out of its traditional operating areas, using a combination of uncrewed surface vessels, anti-ship missiles, and exactly the kind of long-range strike doctrine described above. Nobody would have predicted before this war that a country without significant warships could meaningfully contest a major naval power's fleet, using a mix of cheap, uncrewed boats and missiles. But it happened, gradually, through a long sequence of individually modest strikes that added up to a genuine shift in who could safely operate where. The emerging pattern with attack helicopters near the Belgorod and Kursk border areas looks a lot like an early chapter of that same story being written in the air instead of at sea. No single FPV strike on a helicopter is going to ground Russia's rotary wing aviation fleet. But a sustained campaign of them, each one forcing more caution, more altitude restriction, more electronic warfare overhead, more reliance on indirect fire instead of close-range gun and rocket runs, has the potential to produce the same kind of slow, cumulative denial of airspace that uncrewed boats and missiles produced at sea. There's a caution worth adding here, too, because it would be easy to walk away from a story like this thinking that FPV drones have simply solved the problem of killing helicopters, and that isn't quite right either. This engagement, even taken at face value, appears to have required a fairly elaborate set of preconditions: extensive advanced reconnaissance to identify likely patrol patterns, a dense enough network of detection assets to get meaningful early warning, multiple coordinated teams positioned along different possible flight corridors, backup equipment on hand for when primary drones failed, which they did more than once during this engagement, and a fair amount of luck around weather, fog cover, and the helicopter's specific choice of route on that particular morning. That's a lot of infrastructure and preparation behind what looks, in the final video clip, like a single scrappy drone chasing down a helicopter. Replicating that kind of result reliably against a wary opponent who is actively adapting countermeasures is a much harder standing problem than pulling off one successful ambush under favorable conditions. Militaries that want to build this capability at scale need to invest in exactly the unglamorous parts of the process: sensor networks, communications infrastructure, operator training pipelines, and above all, the patience to let strike teams sit in a tree line for hours, waiting for a target that might never come, or might come and pass by untouched because a battery connector corroded at the wrong moment. The viral video is the easy part to imagine. The infrastructure underneath it is the hard part to build, and it's the part that actually determines whether an isolated success like this becomes a repeatable tactic or stays a one-off headline. Taken together, what this engagement over Vyazvoye really offers isn't a tidy verdict on whether drones have made attack helicopters obsolete. They haven't, but a concrete data point in a much longer, still unfolding argument about where the balance of air power is heading in an era when cheap, networked, expendable systems can be built and fielded faster than expensive crewed platforms can be replaced. Whether this particular Mi-28 ultimately came down in a field near the border or limped back to base with a damaged tail boom for repair, the tactics behind the attempt, layered detection, distributed strike teams, real-time replanning, jam-resistant control links, and a deliberate choice of the airframe's most vulnerable point represent a genuine evolution in how a numerically and technologically outmatched force can still credibly threaten some of its opponent's most capable assets. That's the part of this story likely to outlast the specific dispute over one helicopter's fate, and it's the part worth paying attention to as this pattern almost certainly repeats itself, on this front and probably on others in the months ahead.